Okay, just a quick video looking at upper and lower bounds. So before you go through this video, you need to make sure that you're confident with rounding. So that's rounding to nearest whole number, tens, hundreds, etc. Also decimal places and significant figures. Okay, so we'll go through these examples. So first of all, if we're looking at a piece of string that's been rounded to the nearest whole centimetre to 7 centimetres. So if we're trying to find the upper and lower bounds of what it could have been, we're basically looking for the shortest it could have been and the longest it could have been. So if it's been rounded to the nearest whole centimetre, and we're somewhere around 7, it could have been rounded to 6, 7 or 8 centimetres. Now to work out the shortest it could have been, we go halfway between 6 and 7, which is obviously 6.5 centimetres. And if we're halfway between 7 and 8, then obviously that's going to be 7.5 centimetres. Now, the problem people have here with this 7.5 centimetres is that they think actually if you round any number if you round that to the nearest whole number, then it would go up to 8. However, the reason we use 7.5 because that is actually the halfway point, is the cutoff. 0.5 only rounds up to the whole number, only rounds upwards because of a convention. It's just that we're all doing the same thing. These are actually the limits of the value of the length of this string. So if we write it as an inequality, we'd write it like this. So x is bigger than or equal to 6.5 because the 6.5 would round up, but it's less than 7.5. It could be anything up to that point. So it could be 7.499999 and so on. So that's why we use 7.5. Obviously, if it was 7.5, it would round upwards. Okay, another example. So the width of a football pitch is 76.2 yards. That's been measured to 1 decimal place. So again, we're looking for the shortest and longest, so shortest and widest it could have been. So if we look at the values around 76.2, so we've got 76.1 and 76.3. Again, we just find halfway between those values. So 76.15 and 76.25. That'd be the lower bound and the upper bound for that one. And last example, a roof tile weighs 54.23 grams, correct to 4 significant figures. So again, we're looking for the minimum, we're trying to find the minimum weight of 30 tiles. So if we start off by, again, finding the lower and the upper bounds. So find halfway between these two, 54.225 grams and 54.235 grams. So obviously we're going to be using the lower bound because we're trying to find the minimum possible weight. But this time it's of 30 tiles. So we're going to multiply this number by 30 to get our final answer, which is 1.6 kilograms rounded to 1 decimal place. Okay, so we can go through a few more sort of exam type questions now. So first of all, if we have a postcard which measures 8 by 6 centimetres to the nearest whole centimetre, we're going to work out the smallest possible area and the biggest possible area. Now, as you would expect for these sorts of questions, if we're trying to find the smallest possible area, we're going to find the lower bound of 8, the lower bound of 6, multiply them together to work out the lower bound of the area. So 7.5 times 5.5 gives you 41.25 centimetres squared to 2 decimal places. Obviously, to find the biggest possible area, we do the opposite. We find the biggest possible value, so 8.5 and 6.5, and we get 55.25 centimetres squared to 2 decimal places. Now, slightly different example. If Kasim is 157 centimetres tall to the nearest centimetre, and Grace is 143 to the nearest centimetre, if we want to find the greatest possible difference, we don't take the upper and lower bound for the upper bound for both of them. So instead, we want to find the upper bound for Kasim and the lower bound for Grace. So we take 157.5 for Kasim and 142.5 for Grace. So we get 15 centimetres, the greatest possible difference. So you need to be thinking about, if we're looking for the greatest possible difference, do we want the upper bound or the lower bound for him, and do we want the upper bound or the lower bound for her? Next, so we've got bales of hay that are 18 inches high to the nearest inch, and bales are stacked 6 high on a lorry trailer, and the surface of the trailer is 36 inches above the ground, again to the nearest inch. What is the lowest bridge that the trailer and bales can definitely fit under? Right, so we need to think about this. If we've got a bridge and we've got a trailer with the bales on it, we've got to think about a worst case scenario. So we're looking for the lowest bridge that they'll definitely fit under. So we want to find the highest that the lorry and the bales can possibly be. So obviously for the trailer, if it's 36 to the nearest inch, then 36.5 is going to be the biggest that can be. And obviously the bale's height has also been rounded to 18. So if we want to find the highest that could have been before it was rounded, then that would be 18.5. And then we just work out the height of the trailer and the bales in that scenario. So 36.5 plus 6 lots of 18.5. So that is the maximum height of the trailer and the bales.